Good afternoon, everybody, and thank you for joining us again for another rendition of the virtual B&H event space. Today, we are very happy to welcome Trevor Jones here. Thanks, Trevor, for joining us.
Thanks for having me.
Yeah, pleasure. Trevor is going to be talking about deep space astrophotography. So if you've been thinking about getting out there, we've had a real nice bunch of events that have come up recently, related to astrophotography. So definitely some stuff that Trevor's going to address, I'm sure, and talk about and teach you some ways how to get better at that. So thank you very much for joining us. Without further ado, Trevor, thanks for joining.
Thanks so much for having me, Scott. So hi, everybody. I am Trevor Jones from Astro Backyard is the website and YouTube channel that I run. And basically, I take deep sky photos or deep space photos from my backyard using a camera and telescope. And it's something that's, it's a pretty niche hobby, but I've seen it grow a lot over the last 5 years. And there's never been so many people that want to know how it's done and the entire process that's involved. So hopefully in the next hour or so, I can take you through the process from start to finish of what it takes to take a deep space image of a nebula or galaxy, and hopefully it sinks in and you understand the process. So I'll share my screen now and hop into the presentation. So that's me there with my little telescope, and that's a photo of the Andromeda galaxy, probably one of the most exciting deep space objects you can photograph, because of course it's another galaxy with its own stars and solar systems in it. So let's get into it. So just a little bit about me. So that's where I'm located there. That's a light pollution map where you see the red and yellow and the green. That's all light pollution radiating from some of the big cities around me. In astrophotography, generally, you take better pictures if you're from in a dark sky location, but most of us are in a light polluted city, and I'm here to tell you that it is possible to take great images from the city, deep space images. So I started astrophotography way back in 2010, and it's been a long, slow journey since then, but very rewarding along the way. So I really got started by joining the Royal Astronomical Society of Canada in 2011, and I started to meet amateur astronomers, and they really streamlined the process of getting better educated about the night sky and astrophotography. There's a lot of astrophotographers in that group. I started the Astro Backyard blog and YouTube channel in 2015 and 2016 just to document and share my progress in astrophotography. I thought it would be helpful for others just to kind of see what I'm going through and learn from me. And it's been a real big success ever since. I'm so honored that so many people follow along with my videos and my blog. Just some accolades. 100,000 YouTube subscribers was huge for me. And then getting a NASA APOD astronomy picture of the day last year was really big. So it's been quite the journey. And yeah, I'm so excited and proud to be where I'm at in astrophotography now. But enough about me. So here's the early days of astrophotography. We're taking pictures of bright objects like the moon and planets through a manual telescope with just a little point and shoot camera. It was a Canon Power Shot at the time. You can see the size of the telescope with our little dog back then, Leo, who's since passed on, sitting proudly next to my first telescope. There's different types of astrophotography. Deep space is what we'll be focusing on this talk, and it's I would say the largest audience of people that are excited about astrophotography are in the deep space realm. So the nebulae, galaxies, star clusters, stuff like that. But there's also nightscapes and Milky Way astrophotography and planetary and solar system. So the reason I like to split up the different types of astrophotography like this is because what you're going after and what you intend to take pictures of really dictates the type of gear that you'll need. And it's quite different for each of them. So for the wide angle nightscape style images, of course, you'll want to use a camera lens as opposed to a telescope, some of those shorter focal lengths. But a star tracker, if you can see that left picture there with my camera lens, is something you'll need to take better nightscape photos. In the middle there is a typical deep space rig with a camera and telescope. That one happens to be a dedicated astronomy camera, and I'll get into the differences between that and say a DSLR or mirrorless camera in a minute. And then on the right is a large telescope, a high magnification, lots of aperture to take those really high magnification images of planets and close-ups of the moon's surface. So focal lengths and F ratio, I know I'm talking to a photography-based crowd here, so a lot of you guys understand this, but the longer focal lengths is really important for deep space astrophotography. If you're photographing smaller objects, of course, you want to pull them in. So, focal lengths of 400 millimeters or more are common in terms of, a lot of the astrophotography telescopes that you'll find. The telescope you see there on the right is, that's a William Optics Z73 refractor telescope. It shares many similarities to, say, a telephoto camera lens, and it shoots at a focal length of 430 millimeters. So that's a great spot to start. They're like a prime camera lens because it has a fixed aperture. They're not zoom or anything like that. So 430 millimeters at f5.9 is very typical refractor telescope specs. And that's what you'll need to photograph, say, medium-sized deep space objects like some of the larger nebulae. Where we get into the shorter focal lengths camera lenses, say 24 millimeters, that's a Sigma 24 millimeter f1.4 lens. That's what you would use for capturing the Milky Way at a wide angle. The mid-range, that 135 millimeter f2 Rokinon / Samyang lens in the middle there, that's some of the really large nebulae. You would use a lens like that. And then if you want to pull in even smaller objects closer, you'll want to use a telescope like I talked about before. That one happens to be a really wide field telescope at 275 millimeters. So cameras for astrophotography, talking to this crowd, I would expect a lot of you own DSLR and mirrorless cameras and lenses, but you might see these cameras like the red one there that are dedicated astronomy cameras being used for astrophotography. And you can think of them like a camera body with all of the extras that you get on a DSLR or mirrorless stripped out. There's no display screen. There's no control on the camera itself. It's basically a big cylinder with a sensor that has a thermoelectric cooler in there to keep the sensor cool for long exposures, and then a big fan in there to blow the air around. And then it all connects to your computer, and you take your images using a computer software to control the camera. So the reason the cameras are built like this is because your DSLR mirrorless camera can take long exposure images of 30 seconds or even 2 to 3 minutes. But of course, that sensor heats up and you get thermal noise and all those issues that come up with long exposure photography with a regular camera. These cameras are meant for shooting 5 and even 10-minute exposures. And that sensor is built for having the shutter open that long to take long exposure astrophotos. So it may surprise you to find out that a really entry-level starter camera kit can do amazing things in terms of astrophotography. So I recently, put this into practice with, I purchased this from B&H, this camera kit of just a Canon Rebel T7 DSLR with 2 kit lenses, the 18 to 55 and a 75 to 300 millimeter. So very affordable in terms of photography gear, but extremely capable what you can do in astrophotography with this. So I'll show a picture, some examples that you can get with a kit like this. So just Milky Way photography is surprisingly simple. You stabilize that camera on a tripod, you leave the shutter open for 30 seconds at a time. You're from a dark sky site, you can capture the Milky Way. And if you've never done this before, it's an incredible moment when you first see the Milky Way and all the stars that your camera is able to collect on the sensor through a long exposure image. So you'll hear this, the term long exposure often in astrophotography. That really is the magic of it all. A camera sensor can record so much light over a long period of time, much more light than your eyes could ever see. So if you see these pictures of the Milky Way and galaxies and nebulae, and you say, well, okay, so is that what you would see through a telescope? Not a chance. You would never see so much detail and light visually through your eye the way a long exposure photo could. Here's some more examples of shots just with a DSLR camera and lens on a tripod. You can start to see the constellations. And if you tap into some of those zoom lenses, you can zoom in on the moon and see that stuff. And these are untracked shots, and we'll get into tracking in a minute. So example settings for night sky photography. So you want to tap into that manual mode on your camera. White balance isn't so important if you're shooting your photos in RAW, because of course in post-processing you can change the white balance and all sorts of other factors. And then a typical exposure untracked with a wide angle lens at least would be about 25 seconds, ISO 1600. So you want to tap into some of those higher ISO settings, makes the camera more sensitive to light, so to speak, to capture more light in a shorter period of time. And then some of those faster lenses, f4 and below, will collect even more light in a shorter period of time because, of course, that f ratio affects light gathering ability. So yeah, like I said, you might be surprised if you take your camera to somewhere nice and dark and take a long exposure image, and you'll start to see some of the brighter stars. And even in the case of that photo you see right here, you can see the Andromeda galaxy just on the right middle of that photo there. So it's pretty incredible if you've never taken a long exposure image before, the excitement that comes along with that. Here's a real beginner level setup using that camera I showed before, the Canon Rebel T7. And that piece of equipment you see it on there is a star tracker. So that one happens to be the Skywatcher Star Adventurer. And all these star trackers do essentially is compensate for the apparent rotation of the night sky. And I say apparent because the Earth is moving, that sky isn't. So we're spinning. And if you take an exposure of 30 seconds or more, especially with longer focal lengths, you'll see those stars begin to trail over time because the night sky is moving. So it's a moving target. To compensate for that, we use these star tracker devices that slowly move at the same speed as the night sky. So then all of a sudden you can take a 2-minute, 3-minute exposure and the stars will be pinpoints if you've aligned it properly. And that is really key to taking deep space photos, is the tracker, a motorized camera tracker. A star tracker is the entry level point to tracking. And then some of those telescope mounts, the more robust mounts that I showed earlier, that's as you level up. And of course, the price tag goes up with those as well. But to hold a big, heavy telescope, you need a more robust equatorial telescope mount. So that's a really good beginner level setup there. So if there's any of you that are new to astrophotography and want to start taking these long exposure images to reveal galaxies and nebulae, a star tracker is absolutely essential. Here's a photo I took recently on that rig that I just showed you on the last screen. This is the Witch's Head Nebula that is right near a bright star Rigel in Orion. So this is a reflection nebula. So that blue dust in the night sky in space is being reflected by that bright star Rigel. Now, this is a notoriously faint nebula, one that is really, really hard to capture in a short amount of time. So I had to put in 3 hours of total exposure time to capture this image. And yeah, so dark skies are essential for certain targets like reflection nebulae, but other nebulae like emission nebulae that have hydrogen gas glowing, you can capture from the city using the right filters. But I just wanted to show you an example of what's possible with a really entry-level setup like the one I just showed. And I'll get into the reason why there's 90 times 2 minutes at ISO 6400. So the signal to noise ratio and stacking are so important when it comes to astrophotography. All these images that you see of these detailed bright nebulae and galaxies are never going to be a single exposure through the camera, even if it is 3 to 5 minutes long. There's something called the signal to noise ratio. So signal is the light that you've collected with your camera sensor, and noise is the artifacts of just the way a digital sensor works. It's, it's something you need to overcome to create a nice image in astrophotography. So by stacking several images together, the light frames pile up on top of each other, and that signal is improved and improved and improved. And the noise actually cancels out because we use software that identifies, okay, this is what noise is. Now we can subtract it from the image. It's pretty amazing. Without stacking and the signal to noise ratio, we would never be able to get these detailed, crisp, smooth photos of nebulae in space. So that's a single 2-minute exposure of the image you see there on the right, as opposed to 90 times 2-minute exposures processed on the right there. So a big difference between that single image exposure and your final image that you pull out. So polar alignment is one of those things that's, it sounds tricky early on, but it comes back down to that tracking accuracy and matching the rotation of the night sky. Here in the Northern Hemisphere, it's extra easy. It's almost not fair how easy it is here compared to the Southern Hemisphere, because we have Polaris, the North Star, as a reference. So essentially, you need to align the polar axis of your tracking mount with the North Star, and then the sky will spin on the same axis as your telescope mount. So there's a bit of fine tuning there, but that's the key alignment procedure to getting proper tracked images. You can't just plunk the star tracker down and start taking pictures and assume that your camera is going to be matching the speed of the night sky. You have to polar align it. That's a remote shutter release there too. So of course, if you're using a DSLR camera or mirrorless, you're probably limited to those 30-second exposures using the bulb or manual mode. A simple remote shutter release cable will allow you to take longer exposure images. And that's one of the first pieces of hardware you'll probably want to invest in if you want to start taking these long exposure tracked images. So star trackers with a camera and lens, like I said, is probably one of the best ways to get started in astrophotography, as opposed to just jumping straight into a telescope. I think it's important to start learning the basics of taking long exposure images, that polar alignment and the tracking, and taking these wide angle images of the night sky. So there are deep space objects in that photo of the Milky Way you see there. I can see the bright ones in Sagittarius, the Lagoon Nebula, and I see the Eagle Nebula in there too. But it's a lot of fun to take these wide angle images, and they of course have the benefit of being a lot easier to accomplish, because as you get into those longer focal lengths and the more magnification, any issues in your tracking or errors in your polar alignment will be magnified. So those wide angle shots of the night sky are probably a great place to start. So, if you are getting into the telescope world, a Dobsonian telescope like the one I showed on one of those first few slides, that's a visual telescope, but you can start taking pictures of the bright objects with your smartphone or even a point and shoot camera. That's a great way to learn the night sky before you really get into the photography world. Deep space, though, a system like this is just, you'll never be able to capture a long exposure deep space image through a telescope like this. Just some examples. It's inspiring what others have done using a smartphone through a manual telescope. So the picture on the right there of the Orion Nebula, these are ones that people on Twitter sent me, is kind of proving me wrong, saying that deep space is impossible with a manual telescope. That photo, it is so bright, that nebula, the Orion Nebula, is one of the few it's possible to get somewhat of a photo through a manual telescope like that, but I just threw that in there. So here's an astrophotography telescope, a refractor. This is one I use all the time, and I've taken many great pictures through it. And I just wanted to show you the guts of a refractor telescope, a really popular choice for astrophotography, and the differences between it and a camera lens and some of the other types of telescope, more traditional type of telescopes you may have seen. So the camera, that's a Canon EOS RA, Canon's current astrophotography camera, attached to the telescope. So it's threaded directly. I'm not putting it through an eyepiece or sliding it in there anyway. It's threaded right onto the telescope itself. This telescope has a focal length of 275 millimeters at f4.5. So, if you compare that to a telephoto lens, those are impressive specs. You can go deep and it's rather fast at f4.5. This one has an adapter with an internal filter slot. So we haven't got into filters yet, but especially if you're planning on taking deep space images from the city, filters are so handy for ignoring the glow of the night sky from light pollution and the moon, and separating the signal from the deep sky object or deep space object that you're photographing. So you can mount accessories on top of the telescope. And of course, it has the mounting hardware to mount to those equatorial telescope mounts that I talked about, which of course is different than a camera lens, because finding balance for a rig like this, as you can imagine, taking these long exposure images where you need it to be ultra steady over a long period of time, balance is really important. So this is a really small telescope in terms of, I'm sure you've seen some of these large 8-inch, 12-inch diameter telescopes. This one's 61 millimeters. So again, very similar in terms of specs to a prime focus telephoto lens. This one happens to be an apochromatic refractor. There's a bunch of different types of refractors, and an apochromatic refractor, or an APO, as they're nicknamed, just has the best color correction. So just the way that the optics and the glass work in a refractor, similar to a lens, you need to focus all the colors of the spectrum at the same point. And without that, you're going to get things like chromatic aberration and color fringing. And astrophotography has a way of exposing cheap lenses, because bright stars, you're shooting an ultra bright star against a black sky. So if those optics aren't corrected well, you're going to see color fringing and all sorts of ugly things you don't want to see in a deep space photo. So here's some examples of some of the deep space photos that I've taken. You can see the Pinwheel Galaxy there, sorry, that's mislabeled. That's the California Nebula there in the middle. I was close, in the right continent at least. And then the Trifid Nebula on the right. So some of these are really some of my favorite deep space objects. And these are the types of images that inspired me early on to say, okay, whatever it takes, whatever I need to do, I want to do this. I want to photograph these objects, and I want to know how. So hopefully this overview will give you a better idea of that. As I said, accurate tracking is a must when you're taking these images. So to make up this picture of the Heart and Soul Nebula, I piled on over 6 hours of total exposure time, and the images were all 3 to 5 minutes each. So everything has to come together to produce an image like this. You'd be surprised at, even when you think you have the basics of balance and polar alignment and tracking, everything running right, it doesn't take much for something to go wrong and ruin one of your long exposure images. So stacking and image processing are key, and your skills in the stacking and processing stage after the acquisition have to come together too. So deep space astrophotography really is the marriage between the best practices in the field of your acquisition with your gear and knowing how to use it, and then the way you're able to edit and bring out these amazing photos in the post-processing using software like a lot of you are familiar with, I'm sure, Lightroom and Photoshop, and some dedicated astrophotography software as well. So this is a great example showing how even a basic entry-level setup is capable of astonishing results. That's the Andromeda Galaxy there, captured with the setup you see on the left. That's the Skywatcher Star Adventure Star Tracker. I highly recommend that specific model if you're looking at getting into a star tracker. And then another really wide field refractor telescope on the left there. So a deep space astrophotography rig with a telescope. And now I've seen this image ripped off online showing like, this is why deep space astrophotography is so hard. Do you want to get into a setup like this? And I was like, hey, that's my image. So I realized that something like this looks very daunting if you've never taken an image of the night sky. But really, this is a pretty intermediate level astrophotography mount there, or rig, I should say. Some things that I haven't talked about that are pictured in this camera that I haven't said yet are the guide telescope and guide camera. So there's something called auto guiding in the world of astrophotography. And all it essentially means is that you have a dedicated secondary scope on top of your primary scope that you're taking pictures with, that's only job is to focus on one star, communicate with your telescope mount to get that tracking accuracy even better. So there's software that sends little pulses to your telescope mount to make little adjustments for better tracking. So that's the art of auto guiding, something you really don't have to worry about to start with. You'll know when you get to a point where auto guiding is something that you need to do to get to the next level for astrophotography. And you can see that one-shot color camera at the end of the telescope in place of a DSLR in this intermediate setup. So long exposures, as I said, when you really pile on that exposure time, it does get to a point where adding exposure time won't do anything for your image. But if you're shooting in light pollution from the city like I am, anywhere from 10 to 20, even 30 to 40 hours of total exposure time will give you better results. And as you can imagine, as I explained, with so many things can go wrong, actually compiling up that much exposure time is quite the task. Because of course you need clear skies and the weather to work out for you too. So to really commit to a project and to collect that much time on an object is a big commitment. And so when you see those photos that are 30 to 40 hours exposure time, you know that's a labor of love, and it may have taken an astrophotographer a season to complete an image like that. So tracking, as I explained earlier, just the comparison of a star tracker and a full-on telescope mount. You can see that polar axis pointed towards the North Star here in the Northern Hemisphere. So tracking accuracy, as I explained earlier, you can see an example of the night sky moving with those moving stars without a star tracker in that picture in the bottom left. When things are tracking properly, you can start to reveal all these incredible details on a deep sky object, deep space object. But like I said, yeah, tracking is absolutely essential, and it is a hurdle to overcome early on, just getting your tracking accuracy on point. So image stacking there, here's a great example image of a single 300-second exposure as opposed to a stack of 22 of those exposures. If you really look there at the Horsehead and Flame Nebula, at how much more you can see of that deep space object in that stack of 22 exposures versus the single exposure. So it's not like you can just attack that single exposure in Photoshop and pull out those details, even if you're a processing wizard. It's just not going to be there unless you've really soaked in a lot of time on the object. And that's one of the funnest parts of astrophotography, I think, is collecting that time on your deep space object and really committing to a project where that, what, if I soak 10 hours worth of exposure time on this, I'm really going to have a real joyful experience in Photoshop, bringing out those details, because they'll be there, and the signal to noise ratio will be so much more improved. Just be a pleasure to process if you've put in the work and collected that much time. So here's a look at building an image with a monochrome astrophotography camera. So a lot of these, there's a lot of one-shot color cameras that are just like your DSLR, where you take a color image in one shot. But there's also monochrome cameras, which actually collect a lot more signal in a single shot than a color camera does, just because of that Bayer filter that you find on color cameras. It's splitting the light into RGB channels for you, but it's only collecting a quarter as much light on your deep space object as a monochrome camera does. To get that color, you need to shoot with your monochrome camera through different color filters, or better yet, these narrow band filters that collect a very narrow wavelength of light at a time. So this is an example of mapping those channels of narrow band wavelengths to specific colors to create a full color image. So you can see there's something called an H-alpha filter used for the red channel here, and then using the O3, an oxygen filter, for the green and blue channels to create a full color image. Here is the result, mapping those specific wavelengths of white light to color to create a full color image. And it may seem, like wizardry, and it is called false color because you are mapping the light to specific colors. But this is how the Hubble Space Telescope works. It's isolating specific gases from these deep space objects and mapping them to specific colors. In the case of the Hubble telescope, in the Hubble palette. So if you've seen these really wild colored nebulae, a lot of those are color mapped images in the Hubble palette. It's not to say that you can't capture these true color RGB broadband images without mapping color too. Those are amazing images as well. But I think when you really get deep into deep space astrophotography, you'll start to crave creating these really dynamic images where you're associating specific gases to colors, and you can really create a dynamic image by highlighting those gases. So image processing, as I said, is a huge part of astrophotography. So if you are really comfortable in Adobe Photoshop and stuff like Adobe Camera Raw and adjusting curves and creating masks are in your wheelhouse, you're going to find deep space image processing a lot more comfortable early on. You'll be comfortable stretching the image and pulling out the lights and bringing down the darks. But there's just so much to it. It really is like nothing else, no other type of photography. And it's something that will take time. There's a lot of great tutorials online for astrophotography image processing. I have a bunch myself, so if you want to watch those on your own time, that might be helpful to you. But yeah, image processing, like I said, is the second half of the journey for astrophotography. So this is a beginner level setup. Like I showed earlier, this is what I would recommend if you're just getting into deep space and you're not ready to buy a huge telescope. Get a star tracker, get a mid-range telephoto lens. That's the Rokinon 135 right there. That's kind of the sweet spot where you can start to pull in some of those deep space objects, some of the larger ones, and actually reveal stuff like the Andromeda Galaxy and some of the larger nebulae. If you just have a shorter focal length wide angle camera lens, of course, you can capture the Milky Way and star fields, and you can pick out those deep space objects as well. But something like a shorter focal length refractor telescope or mid-level telephoto lens like this is what I would recommend. And these are the types of projects you could attempt with a rig like that. So example images there, that's the Carina Nebula in the Southern Hemisphere on a trip to Costa Rica. I captured a 9-minute exposure was all that was needed for that one. It is just so bright. And then the Milky Way with a DSLR and a 24mm lens on the right. And you can pick out some of those bright nebulae in the constellation Cygnus in the middle there, the North American Nebula. I see the Butterfly Nebula and even the Elephant's Trunk Nebula. You'll find these objects have really funny names sometimes. The intermediate level setup here with a DSLR and telescope, that's when you get into the more, it gets a lot more technical in a hurry in terms of, your refinement of your alignment process, the polar alignment, and needing extra accessories to pull off a great image like auto guiding. And there's tools like, there's something called the Pole Master, which helps you polar align. Everything gets intensified as you get into an intermediate level setup. These are examples. Of course, because we have more magnification, we can pull these deep space objects in closer. That's the Orion Nebula on the right and the Lagoon Nebula on the left, shot with setups very similar to the one I just showed. And then there's some free tools that you'll want to use to help yourself out. Stellarium is great. It's a planetarium software. It's, I use that app on a daily basis to see, where the moon's going to be in the sky, where objects are this time of year, and then a light pollution map for planning your trips. And then some of the actual software that's specific to astrophotography, Deep Sky Stacker, Sequator, Nina, and then some paid tools that you're probably used to, Adobe Photoshop. And then there's dedicated acquisition software tools like one that I use called Astrophotography Tool. So if you want to learn more, you can visit my website, astrobackyard.com, which is largely a blog where I documented my experiences in deep space astrophotography over the last 10 years. So if you go back to some of those older posts, you really see the learning curve and the growth there. Speaking of the growth, that brown photo on the left is my first deep space astrophoto I ever took through a telescope. There's a dim galaxy in there, believe it or not, that smudge. And I was over the moon to capture that at the time. And then on the right is one of my more recent photos of inside the Eagle Nebula, the pillars of creation. And it's, that's a photo made famous by the Hubble Space Telescope. So the fact that, I was able to take an image that even resembles an image taken by Hubble was just mind blowing to me. So that's how far I've come in my time. So I think we're going to open it up to questions, and hopefully there's some good ones now.
Yeah, excellent. Trevor, thank you so much. That was a great presentation and some great information. We definitely have a lot of questions that have come in, and I think we should just start with my favorite so far. I thought this was a great question, something that you didn't really touch on, and something kind of an interesting thought. Mark is joining us on Zoom, and he wanted to know, can you use a medium format camera with a telescope?
Of course, yes. So in terms of cameras and their pairing with telescopes, a lot of times it just comes down to finding the right attachment to get it to thread to the telescope, and the types of filters that are available to you to use for the coverage of that camera sensor. So I use a lot my Canon EOS RA, which is a full frame sensor camera body. And of course, to cover that sensor, I need those larger 2-inch filters. So it's just stuff like that you have to think about. But pretty well, any camera can be used for astrophotography, whether it's with a lens or with a telescope.
Just maybe not a cell phone. But
no, yeah, yeah.
At least not for anything that you're shooting at that level.
Yeah, just the phone sensors just weren't meant for, it's too demanding for a little phone sensor.
Yeah. Caleb is joining us, and he actually, to kind of mimic that, kind of wanted to know, in your own preference, do you prefer using a DSLR or something with a CMOS CCD?
So in terms of user experience, I really do enjoy using a DSLR just to have that screen on the back. And I like to, you can focus and use live view and all those great things, adjust settings on the fly. And of course, it's also more portable too. So, if I'm going camping or I'm traveling, the DSLR is much more practical than bringing a computer with me and connecting the software to run that dedicated camera that you can't control anything by on the camera itself. So a DSLR is just a lot more practical. It just doesn't have some of those advanced features that a dedicated astronomy camera has.
Awesome. And then Sanjeev is joining us on Facebook and wanted to know, you did mention, getting the star tracker, and appreciate the brand agnostic, conversation there. But, do you have any recommendations? Are there preferences that you have in terms of brand that you might recommend?
So there's two really good ones that I can bring up offhand. So the Skywatcher Star Adventure, I believe it's the most popular star tracker right now in the industry, and it is for good reason, because it is reliable. It's battery powered. It uses AA batteries. So if you can imagine, you've traveled so far and you're at a dark sky site, and if you didn't charge one of the other models and you're just out of luck, you can't charge it. So I do appreciate that one with the AA battery specifically, because you could bring some extras. And then the Ioptron Skyguider Pro is pretty well, just as good as that one, although it is a lithium ion battery that needs recharging. So I think the Star Adventure edges it out there, but those are two really great models.
all I'm sure, which you can probably find on our website at B&H Photo, hopefully, right?
The Star
Maybe
Adventure
not.
for sure. Yeah, I've seen it. Yeah.
Yeah. So a shameless plug for us, help us out here. Jack is asking, with something like a portable star tracker, how would you recommend setting the polar alignment? And once that's done, how do you next get to the target that you're actually looking for?
That's a great question. So, finding targets in the early stages is a challenge to overcome. So that's one of the reasons I say stick to the really bright, easy targets to start with, because so the polar alignment process, once you have that done, and I should have said this, you have to leave it and it has to stay polar aligned. And you have to add a counterweight to the star tracker, so you can't easily bump it around. It needs to be stationary. The mount does. But then, of course, you're moving that camera lens around to find your object. And it can be difficult, but the process involves using something like stellarium, like I mentioned earlier, as a reference and saying, okay, so this bright object, say the Butterfly Nebula, is right near the bright star Satyr. And I know where that is in the night sky and I can actually see it. So why don't I just point towards that bright star Satyr, take a test exposure of 30 seconds. And if you're lucky, you'll start to see some of that nebulosity come through in a test exposure. Frame it up like that. Once you're framed up nicely, then you can start taking your longer exposures. But yeah, it is hard to frame up and find some of the dimmer targets without the aid of having a computerized mount to tell you where it is.
Right. Technology is your friend. That's
That's
it.
right.
Living in
Always.
a digital era.
We're spoiled. Yep.
That's it. Scott's joining us. Hey, Scott, it's Scott here. Scott is joining us from live stream. He's a huge fan. On average, how much time do you estimate that you spend on actually processing your images?
The average is probably somewhere around 7 to 8 hours. So, one thing I should mention, like with great data, the process actually doesn't take as long. When you have to really dig your image out and reduce the noise and sharpen it and everything, you can spend a long time processing photos. I've spent upwards of 20 hours on a photo. So it really depends on the look you want to achieve, but I would say 7 to 8 hours is probably the average.
Yeah,
which is a lot.
Yeah, not a short amount of time.
No.
definitely get a comfortable, cozy seat and get ready to get to work.
That's right.
So Caleb and Rob actually had questions that they shared with us that kind of mimic on each other. Caleb wanted to know what your favorite DSO is. And then Rob wanted to know if an entry-level tracker would accept the commands to find a specific DSO.
So my favorite deep space object is probably, I honestly don't know. There's so many good ones. What comes to mind is the Andromeda Galaxy, just because of it's awe-inspiring, and it's not surprising at all when I share photos of the Andromeda Galaxy. It really provokes, thought and wonder about space itself. I think because you are looking at a spiral galaxy, which, we're in a spiral galaxy too. So you start to say, wow, is there someone in that galaxy photographing ours from there? And it's mind blowing. So the Andromeda Galaxy is probably my favorite for that reason, just the thoughts it brings out. And then the other question was, it was about finding deep space objects?
Yeah, would an entry-level tracker accept the commands to find a specific deep space object?
No, so those entry-level trackers are really, you could say they're point and shoot. There's go-to telescope mounts that are a bit of a step above these trackers, where you actually do a star alignment routine where you tell the mount, say, okay, this is where Polaris is, this is where Arcturus is, and then it knows the night sky. And you can say, okay, now go to the Cave Nebula, and boom, it goes right to it. But the star trackers are more do-it-yourself, at least for now in that category.
Great. So guys, keep sharing the questions. We've got tons coming in, so we appreciate them. We might actually be here as long as processing an image. So that's the good news. Michael wants to know, when you do remote imaging in the winter, what are some suggestions to keep yourself warm while you image?
Oh, that's a good one. Yeah. So in the winter, I mean, even on a night that's hovering around 0 degrees Celsius, where you're like, okay, I'm comfortable. I've got a winter coat and boots on and everything. It starts to get very cold after you're out there for an hour or two. It's just like camping, right? You're freezing in the tent, even if it was kind of a warm day during the day. So layers is the best thing. You want to wear, like a lot of guys have these like full body suits. Essentially, you need to overdress to stay warm for a night of imaging. I also have a portable propane heater called Mr. Heater. And that has been really handy. And I plunk it right down next to me and just kind of hover around it. A lot of astrophotographers will set their gear up, and once it's running, of course, you don't need to touch it for hours on end. Sometimes they'll sneak back inside to stay warm. But if you're going out all night, then yeah, layers and a portable heater would be my recommendations.
Great, good switch of gear. Different kind of gear question, and then we'll revert back to the regular gear, the camera gear, that kind of stuff. When Steve's joining, when you're taking a stack of photos with the DSLR over, say, several nights, and you have to assemble and disassemble your rig every single night, what do you try to do to replicate in order to keep all of those photos lined up? Are you using focal length, the orientation of the camera? What are you using as kind of a baseline?
Yeah, so of course, if you're going after the same target over multiple nights, of course, you want to, you'll need to shoot the same focal length, the same filter you're using for that matter. If you're going to stack it all together, you want to replicate the entire process that you did the night before. And in terms of framing it up the same way, use a reference image. So if you're storing the images on your memory card, which I do quite often, especially if I'm using a star tracker, go into, preview the image, see exactly, say that bright star Satyr is in the left corner hand side of the screen. Do your test exposures, line it up, get it in the same spot. Use those stars as a reference point. Thank God for those stars to use as a reference point for these dim objects, because without those, it would just be so hard to find these objects and replicate the same image framing night after night.
Right. Look to the stars.
That's the answer.
There you go. Vasilis is asking, he's new to astrophotography, and he's wondering, in your personal opinion, would you recommend that he upgrade his kit lens or go for something like a Skyguider Pro next?
I would say do the star tracker before upgrading your lens. You'd be surprised at the amazing images you could take with that kit lens once you start tracking the night sky. It really is the X factor, the game changer for astrophotography. Once you start tracking the doors, it opens up to the types of projects you can shoot, as opposed to, don't think you need just the nicest glass to get these great photos right out of the gate. I'd go for that Skyguider Pro. Use your budget towards that before your lenses, and then you can look at lenses later.
Right. And so this is I think a good segue into a question that we're getting a lot of here. As far as tripods go, for all these star trackers, what's the recommendation there?
So you want something super solid here. One of those cheap, flimsy tripods that you can get for $20 to $30 is not going to cut it.
No,
no. I mean, and that's in photography in general. You get what you pay for, but especially in terms of tripods, I can just imagine. You invest in this kit for astrophotography, the tracker, and your nice glass, and your potentially a telescope. You do not want to put that on a cheap tripod that you just don't trust. So something that's really sturdy, and maybe carbon fiber if travel astrophotography is something that you're into, because that'll get heavy over time. So a combination of lightweight and sturdy is what you want to get. And like I said, you get what you pay for. So if you spent, I would budget at least $200 to $300 for your tripod if you're going to put that all your gear on there.
Awesome. Ed is joining and would like to know, do you always take all calibration frames, or sometimes do you just kind of wing it and just pray, look to the sky?
So the thing about calibration frames, and when I said about subtracting noise and all those things, there's these things called calibration frames, like flat frames and bias and dark frames, and they're all things that the stacking software used to identify ways to correct your image. Largely noise, but also removing dust and vignetting and stuff like that. No, I don't always take calibration frames. You can get away with just light frames, especially if you're under dark skies. If you're in a light polluted area, that's where you really benefit from all those calibration frames, because you're going to have a large gradient in the night sky from where the light is radiating, depending on the direction you're in, stuff like that. So no, I don't always use calibration frames, but if you do put the time in and you learn how to properly take them, it's usually worth the effort.
Great. And I think talking about light pollution a little bit, we did get a question about that. Do you see that obviously light pollution is getting worse? How do you deal with that? Do you notice that so much out there? And in conjunction with that, a lot of places that you might be photographing from now, we're switching from regular old incandescent bulbs now to the LED technology. How do you kind of conquer that and work through that without that being a factor?
It is unfortunate that light pollution seems to be getting worse and not better. And yeah, I dealt with it personally with the switch over from the old yellow warm lights to the bright white, almost blue lights right outside my house. And you know what? You see less and less stars in the night sky. It really is so sad, the amount of people that have never seen the Milky Way because they've only been in light pollution their entire life. So ways to get around that, there's a lot of light pollution filters, more so now than ever. And they're getting pretty advanced where they're able to cancel out certain wavelengths of light and not others. So it allows you to collect the light associated with your object, but it blocks out like the wavelength that most street lights have. So those filters are pretty magical. But that being said, there's no replacement for dark skies. If you can get away from light pollution, which is increasingly difficult, you're always going to take better astrophotos than you could from a light polluted area.
Awesome. And I think this is one that we haven't touched on yet. Matt is joining us from Facebook and wanted to know what white balance setting do you use typically, especially for things like the wider shots, the Milky Way.
So yeah, if I was just shooting in JPEG or something, I'd probably have it set just to auto or daylight. Those are the two settings that I would recommend. You could create a custom white balance yourself if you're shooting photos like that, but really you want to take all your photos in raw format so you can manipulate that white balance after the fact anyway. So white balance isn't so important if you're taking these raw image format images, but auto and daylight are what I recommend, where they're going to see a bright white star is the same bright white of the sun, right? So those are the two settings I'd recommend if you are using your white balance and it's important to you.
Awesome. And then Dale wanted to know, have you ever had your DSLR sensors modified, such as removing the IR filter?
Yes, I have. So I've used both cameras that I've modified myself to remove that IR cut sensor, and I'll explain what that means in a second. And also Canon has made a few astrophotography DSLRs and mirrorless cameras, the latest being that EOS RA, which is incredible. And that's what it's done. It's taken off that stock IR cut filter that a regular daytime camera has, that's used for better color balance. Like without that, skin tones specifically look too red. So it blocks that out. But in the night sky, emission nebulae glow in that very specific wavelength of red light. So if you're blocking that, you're only getting half the experience, or a quarter of it. So yes, I've both modified cameras and bought pre-modified astrophotography cameras. But I'll say this, don't think that you need an astro modified camera to enjoy the hobby and to take amazing images of space. It's only certain types of images that will really benefit from that process.
Awesome. And then do you have a preferred filter that you use?
Yeah, so for light pollution, the one that comes to mind is it's called the Optilong L Pro filter. And that's one of the multi band pass broad spectrum filters that I said was more advanced, where it's really trying to preserve as much of the light that you want and canceling out those specific ones that we know are associated with artificial light. So that one jumps out at me for light pollution.
Awesome. Doug joining us here from Zoom. Thank you very much, Doug. He's living in Alaska right now. So he wants to know, with those trackers, is there a limitation for latitude?
So there is, I know specifically for one of the accessories, the wedges that actually, allows you to adjust the altitude, that there's a north and south versions of that where, yeah, you're really at the extreme there. I'm not sure. I believe they can go all the way. So no matter where you are on Earth, you'll be able to adjust that latitude adjustment. I don't know Alaska specifically. I don't know of any photographers actually shooting there, but definitely some really northern locations are getting it done. Yeah, so I'm at 43 degrees north, so it's kind of right in the middle of that wedge and the orientation there. But I'd be surprised if they can't handle your latitude.
Great, great. So we got you covered in Alaska.
Yeah,
That's the good news. We did get a few questions about processing of the images as well. We talked a lot about gear and different, things that we can get set up, tripods, cameras, filters. But let's talk a little bit about, post-processing. Mark is joining us and wants to know, in reality, how skilled do you really need to be in things like, say, Photoshop, for instance, in order to process the images? Do you do a lot of post?
so the funny thing is, it's all about your level of expectation. You need to go in it with a practical approach and not expect to get a Hubble quality image right out of the gate. I mean, it seems obvious, but so my personal journey, that image I showed him in the slideshow of that smudge, to be able to see a smudge and know that it was a galaxy was a huge victory for me. And that didn't take a lot of processing just to bring that sky brightness down and bring the brightness of that galaxy up. So you really can be completely beginner level and still be blown away with your results. If you've mastered well, not even mastered, but understand the basic principles of the acquisition stage. With good data, you really don't have to know much about, say, Adobe Photoshop, which is pretty well the go-to software to get a respectable image. Now, with that being said, like anything else, you'll learn more and more and more and get more advanced and more advanced. And these little things that you can do to the image over time when you get better with masks and separating the elements of the image that you want to manipulate and not others independently from each other, that's where it gets really interesting. And those are the types of techniques being used by some of the best astrophotographers in the world. But I say if you're comfortable with Photoshop, even on a beginner level, it will not hold you back, at least in the early days of producing an image that's really exciting to you.
Awesome, great. And we'll finalize here with the last question from Ed here. He happens to be a huge Photoshop advocate. I think we can all relate to that, right? Uses it for all of his deep sky images. Like him, are you feeling the pull of the PixInsight dark side?
Wow, yeah, I am. It's funny timing. So tomorrow I'm putting out on my YouTube channel an astrophotography image processing tutorial that's a half-hour long. And for the first time, I use PixInsight for some of the processes in there. So for those that don't know, it's just a really advanced astrophotography specific software that, it takes a huge steep learning curve in there. And I've resisted it for a long time because there is so much you can do in Adobe Photoshop. Like anything else, with the right tools, if you know how to use them, you can probably get even farther along than if you didn't use them. So definitely not necessary to take, to produce amazing images, but there are some great things about that software. And yes, I have joined the dark side officially as of tomorrow, I guess.
Awesome. We'll cue the music for the dark side. So great. For anybody who wants to connect, maybe has other questions, wants to check out some of your work, or just check out the YouTube channel as well. Do you want to just kind of shout that information out so everybody has it?
Sure, yeah. So I was fortunate enough to get that Astro Backyard username across the board. So you could just Google Astro Backyard and just pick the type of content you want to see. But the YouTube channel is where it's almost weekly new content of me capturing images and processing everything about astrophotography. Astrobackyard.com is where I have the blog and a lot of tutorials there and gear reviews. So between those two and just following me on the social channels, Instagram, Facebook, all that good stuff, there's something for everybody there. So
Awesome. So check them out. Astro Backyard. Trevor, thank you so much for joining us. I hope this was informative for everybody as much as it was for me. I've learned a ton of stuff about the sky just in this. It's so much. It's so vast. So really, thank you very much for joining us. Everybody, make sure to tune in later on. We'll be back. Here's catching you on the next rendition of the B&H Virtual Event Space. Thanks again, Trevor.
My pleasure. Thank you.